Hello, beginners. Welcome to this comprehensive guide on creating user-defined exception classes in C Sharp. Today, we'll explore how to handle runtime errors gracefully and efficiently within your applications. Exceptions are fundamental mechanisms in C Sharp for managing unexpected events that disrupt your program's normal execution. While the .NET framework provides many built-in exceptions, custom exceptions allow you to define specific error conditions unique to your application's domain. Creating your own exceptions significantly improves code readability and maintainability, making it easier to understand the nature of an error when it occurs. This structured approach to error handling ensures your application remains robust and user-friendly. A key tip for custom exceptions is that they make your code more expressive, allowing you to signal precise problems. This clarity helps other developers quickly grasp the intent behind an error, leading to faster debugging and more stable software. Before diving into custom exceptions, let's briefly recall the basics of exception handling using try, catch, and finally blocks. These constructs form the backbone of robust error management in C Sharp. The try block encloses the code that might throw an exception, while the catch block is responsible for handling specific exceptions that occur within the try block. The finally block always executes, regardless of whether an exception was thrown or caught, making it ideal for resource cleanup. Consider a built-in exception like divide by zero exception. If you attempt to divide by zero, the runtime automatically throws this exception, preventing your program from crashing unexpectedly. This example demonstrates how built-in exceptions provide immediate feedback for common programming errors. However, for application-specific issues, custom exceptions offer a more tailored solution. A crucial tip for creating custom exceptions is to always inherit from system, exception, or one of its derived classes. This ensures your custom exception integrates seamlessly into the .NET exception hierarchy. Inheriting from system, exception provides your custom class with all the necessary properties and behaviors of an exception, such as message, stack trace, and inner exception. Now, let's dive into creating our own user-defined exception class, a fundamental step for robust application development. We'll build a simple invalid age exception step by step. The first step is to define a new class that inherits directly from system exception. This establishes it as a valid exception type within the C# ecosystem. Next, we need to implement the standard constructors. The default constructor allows you to create an instance without any specific message. The second constructor takes a string message parameter, which is then passed to the base exception class constructor. This is crucial for providing descriptive error messages. The third constructor is vital for exception chaining. It accepts both a message and an inner exception, allowing you to preserve the original cause of an error. This constructor pattern is a best practice, enabling you to wrap lower-level exceptions with more application-specific ones, providing a richer context for debugging. A helpful tip: always include the inner exception constructor for chaining. This practice provides a complete audit trail of what went wrong, which is invaluable during troubleshooting. Optionally, you can add custom properties to your exception class to store additional, specific information relevant to the error. For instance, an invalid value exception might include the actual invalid value. This allows handlers to access more context than just the message, enabling more precise error reporting or recovery actions. Remember, the goal is to provide as much useful information as possible. For scenarios involving remoting or serialization, mark your custom exception class with the serializable attribute and provide a protected constructor for deserialization. This ensures proper functionality across application domains. Now that we've defined our custom exception, let's learn how to throw it when a specific error condition is met within our application logic. This is where your custom exception becomes active. To throw a custom exception, you use the throw keyword followed by a new instance of your exception class. This immediately halts the current execution path and signals an error. Consider a method that validates user input, such as an age. If the age is negative, it's an invalid condition that your application needs to explicitly handle. Inside this conditional block, we'll throw our invalid age exception with a descriptive message, clearly indicating why the age is considered invalid. This approach ensures that any code attempting to set an invalid age will immediately be notified of the problem, preventing further erroneous processing. A crucial tip: Throw exceptions only when a specific condition fails and cannot be handled locally. Don't overuse exceptions for normal program flow, as this can impact performance and readability. It's a best practice to throw early, fail fast. This means validating inputs and throwing exceptions as soon as an invalid state is detected rather than allowing the program to continue with bad data. Let's see a complete code snippet demonstrating how to integrate throwing our custom exception within a method and how it would look in a larger context. This method clearly defines the valid range for age and uses our custom exception to enforce that rule. Any caller of this method must now account for the possibility of an invalid age exception. Now that we know how to throw custom exceptions, the next critical step is to learn how to effectively catch and handle them. Proper handling ensures your application recovers gracefully. When handling exceptions, it's crucial to catch the most specific exception types first, followed by more general ones. This allows you to provide tailored responses to different error conditions. Let's integrate our invalid age exception into a try-catch block. We'll attempt to call our processor method and specifically catch our custom exception.
Within the catch block for invalid age exception, we can access the exception's message and display it to the user, providing clear feedback about the invalid input.
Following the specific catch block, you can include a more general catch block to handle any other unexpected errors that might occur. This acts as a fallback. A vital tip for handling exceptions is to log the full details of the exception for debugging purposes. This includes the message, stack trace, and any inner exceptions. However, when presenting errors to the end user, always provide user-friendly messages. Avoid exposing internal technical details that could confuse them or pose security risks. Proper exception handling ensures that even when errors occur, your application can either recover gracefully or inform the user in a helpful manner, maintaining a positive user experience. Now, let's explore some best practices and advanced tips for working with custom exceptions, ensuring your error handling is robust, maintainable, and efficient. Always follow the naming convention of ending your custom exception class names with exception, such as invalid age exception or product not found exception. This makes their purpose immediately clear. Ensure your custom exceptions are serializable, especially if your application involves remoting, cross-process communication, or storing exception details. This allows them to be correctly transmitted and reconstructed. Avoid throwing exceptions within constructors. Constructors should ideally succeed or fail by leaving the object in a valid state, or by throwing an exception that indicates a fundamental problem with object creation. Instead of throwing in constructors, consider using a factory method or a separate validation method that returns a Boolean or throws an exception before the object is fully constructed. As discussed, add custom properties to your exception classes when they can provide valuable context beyond the message. For example, an invalid value exception could expose the value that caused the error. This allows the catching code to make more informed decisions or provide more specific feedback to the user, enhancing the overall error handling capabilities. A critical tip: thoroughly test your exception handling logic. Write unit tests that specifically trigger your custom exceptions and verify that they are caught and handled correctly. This ensures that your error handling is as robust as your core application logic, preventing unexpected crashes or incorrect behavior when errors occur. Finally, remember to use predefined exception types when they adequately describe your error condition. Only create custom exceptions for truly unique, application-specific scenarios. You've now learned the essential steps to create, throw, and handle custom exceptions in C#. This knowledge empowers you to build more resilient and user-friendly applications. We covered understanding exceptions, defining your own custom class, throwing it when conditions are met, and handling it gracefully with specific catch blocks. We also explored best practices like naming conventions, serializability, avoiding exceptions in constructors, and the importance of thorough testing. Now it's your turn. Practice implementing custom exceptions in your own C# projects. Experiment with different scenarios and see how they improve your code's robustness. Thank you for watching this tutorial. We hope you found it informative and helpful in your journey to master C# exception handling. Happy coding!